This is Lesson 92 in Saxon's Algebra 1, 3rd edition book. This lesson is about uniform motion problems concerning equal distances. Now we'll do some later that have unequal distances, but this one is the easier, and we'll start out with it when doing these types of problems. So we know that from science that to find distance, we would say rate times time. For instance, if I say that I went 50 miles an hour and I traveled, I did that for 3 hours, then I can figure out that I went 150 miles because the rate of 50 miles an hour times the time of 3 hours gives me a distance of 150. So distance does equal rate times time, or like it says here, D equals RT. Okay, now in the word problems that we're going to be doing, usually they'll have some statement about rate and some statement about the time. But sometimes students have a hard time putting that into an actual equation to find distance. So just because of the way it's worded. So since this one is kind of troublesome, we're going to consider this equation to be the key equation for this type of problem. We'll always write this equation first. D equals RT. Okay? Then we're going to take all the equations that concern time, and then the ones that concern rate, and then when we have all the equations and independent equations as we have variables, we're going to either use substitution or elimination to solve to find out the unknowns. Alright, so if you saw a picture of it, the two types of problems we're going to have in this category are going to be either that two objects left at the same time and they're traveling in the same direction, or they left and one's traveling north, say, and one's traveling south, or one's going east and one's going west, but they go the same distance. Okay, so in this case we can say that the distance of one is the same as the distance of two, or equal distances. Okay, so let's work some word problems where you're going to be doing this. Okay, the first one. On Tuesday, the express train made the trip in 12 hours. On Wednesday, the freight train made the same trip in 16 hours. Find the rate of each train if the rate of the freight train was 15 kilometers per hour less than the rate of the express train. Okay, so we're going to say first, we've got the express train and the freight train. Those are our variables. And the distance of the express and the distance of the freight, they're going to go the same distance because it's the same trip, okay? Now, we know that distance equals rate times time. So the distance of the express is equal to rate of express times time of express. Same thing for the distance of the freight. It equals the rate of the freight times the time of the freight. All right, let's see what we can pick out, what equations we can pick out. We know that the time of the express train was 12 hours, so TE, right here, would be 12. We know that the freight train made the same trip, and its time, though, was 16 hours, so time of the freight is 16. Now, what do we know about the rates? We know they did not have the same rate, obviously, or they would have made the trip in the same amount of time. What we do know about the rate is that the rate of the freight train was 15 kilometers per hour less than the rate of the express train. That makes sense, right? Express trains are faster than freights. So, what can we do to make this an equal statement? Well, we can say that the rate of the express would be equal to the rate of the freight train if we added 15 to the slower one. Then we would have the same rate, equal rates. All right, so now that we've set up, we've extracted all the equations that we can from the wording in the problem, we're going to set up our equal distance problem. Rate of the express, time of the express, or distance equals rate of the freight times time of the freight. All right, now we have something here that we can substitute in to this equation right here. So we're going to put RF plus 15 times our time of the express, which is 12, equals the rate of the freight times the time of the freight, which is 16. So when we do our distributive property, we see that 12RF plus 12 times 15 is 180 equals 16RF. If I subtract 12RF from both sides, I will see that 180 is equal to 4RF. When I divide by 4 to get RF isolated by itself, I divide this by 4, and I'm going to find that the rate of the freight train was 45. Now, I don't know the rate of either train. Okay, so it said find the rate of each train. So I found the freight is 45, and I know that the express is the freight plus 15. So if I substitute that 45 in there, then I'm going to find that the rate of the express train was 60 kilometers per hour. Okay? In example 2, the members of the girls' club hiked to Lake Tenkiller at 2 miles per hour. Mr. Ali gave them a ride back home at 12 miles per hour. Find their hiking time if it was 5 hours longer than their riding time. So that's the first thing we're going to find. And then, don't get tripped up, it also asks us the distance. How far was it to Lake Tenkiller? So let's start extracting what we know. We know that the distance of the hiking is equal to the same distance as the distance riding. So we can take this D and change it to RHTH is equal to RRTR. All right, let's pull out what we know. All right, we know that their hiking rate was 2 and their riding rate was 12. So in this one we know the rates, we don't know the time. The only thing we do know about the time, they are not equal, but the hiking would be equal if I added 5 to the riding time. So now I know that the time of the hiking is equal to time of the riding plus 5, because riding was obviously faster. All right, so let's substitute in what we know. We know that 2, which is the rate of the hiking, times the time of the hiking, which is TR plus 5, is equal to 12, the rate of the riding, times TR, the time of the riding. Do your distributive property. 2TR plus 10 equals 12TR. Subtract 2TR from both sides, and we'll have 10 equals 10TR. Now we're going to divide this by 10 to get TR by itself. 10 divided by 10 is 1. So the time of riding was just 1. So the time of hiking then would have been 1 that we just found, their riding time, plus the 5 of hiking. Okay? So the time of hiking then would be 6 hours. So now we can take either one of these. We can take 1 times 1 TR times 12 RR, and we would get 12 for our distance. Or we can take the 6 here, the time of the hiking, times 2, the rate of the hiking, equals the distance of the hiking. We're still going to get 12. So either one. 1 times the 12 TR times RR, or TH times RH, which is still going to give us 12. Example 3. Durant drove to the oasis in 2 hours, and Medill walked to the oasis in 10 hours. How far was it to the oasis if Durant drove 16 miles per hour faster than Medill walked? Alright, so we have a driving time and a walking time. So we're going to have distance of driving equals distance of walking. So instead of distance, we're going to put RD/TD equals RW/TW. What do we know? We know that the time of driving was 2 and the time of walking was 10. We know that the rate is not the same. The rate of driving would be the same as the rate of walking if we added 16 to the rate of the walking. Okay, so we're going to substitute this in right here for RD, and then for TD we have 2, RW and TW we had 10. So now it's just a matter of simple substitution, distributive property, and when you do all the math, you're going to find out that the rate of walking was 4. Alright, now it says how far was it, so it's wanting to know the distance. If we know the time of walking, okay, and now we know the rate of walking is 4, then we can say time times rate equals distance. So 10 times 4 would be the distance, or we could put this 4 in here and say 4 plus 16 is 20, and 20 times 2, because driving and driving times each other, would be 40. We're going to get the same answer either way. It was 40 miles. Alright, let's do our practice problem. Candace and Pangloss walked to the site of the disaster in 9 hours. The next morning they jogged back home in 3 hours. How far, that's distance, did they jog if they jogged 4 miles per hour faster than they walked? Alright, so we know that the distance of walking is equal to the distance of jogging, okay, to the site, okay. Now, so we can change that into RW/TW equals RJ/TJ for walking and jogging. We also know that the time of walking was 9 hours and the time of jogging was 3 hours. So we know both times. And the only thing we know about the rate, they're not the same. So we know that the rate of the jogging would be the same as the rate of walking if we added 4 to it, because they jogged 4 miles per hour faster than they walked. Alright, so now that we know all that, let's go in and set up and substitute in. Okay, RW/TW equals RJ/TJ. Substitute in what we know. We're going to be solving for RW, and TW is 9. Equals RJ is RW plus 4, and TJ is 3. Alright, so we're going to have 9 RW equals 3 RW plus 12. If I subtract 3 RW from both sides, I'm going to have 6 RW is equal to 12. Divide by 6 on both sides, and RW, the rate of walking, is 2. Now it says how far. So, how far did they jog? Alright, the rate of jogging is equal to RW, which is we now know is 2, plus 4. So the rate of jogging was 6. How far did they jog? Rate of jogging times time of jogging would give us distance. The time of jogging was 3, so 6 times 3 is 18. So it is 18 miles. Okay, and our last practice problem. On Monday, Voltaire drove to town at 60 miles per hour. On Tuesday, he drove to town at 40 miles per hour. If the total traveling time for both trips was 15 hours, how far was it to town? All right, we know both the rates, and we know something about the time. So Monday's rate was 60. Tuesday's rate was 40. And what do we know about the time? We know that the time of Monday plus the time of Tuesday is equal to 15. The total driving time for both was 15. Okay, so TM plus TT is equal to 15. Now, so that I can have something I can substitute into this equation over here, I'm going to say I'm going to subtract TT from both sides, and I'm going to get TM is equal to 15 minus TT. So with my equation, RMTM equals RTTT, and I now know that RM is 60, and TM is 15 minus TT, and RT is 40. And right now we're solving for Tuesday's time. So 60 times 15 is, let's see, 6 times 15 is 90, so that would be 900 minus 60 TT equals 40 TT. So now I'm going to add 60 TT to both sides. And I get rid of it over here. 900 is equal to 100 TT. Divide by 100. And I'm going to get my time of Tuesday is 9. And I'm looking for distance. How far was it? All right, so if I know the time for Tuesday and I know the rate for Tuesday, rate times time, distance equals rate times time. So the distance would equal the rate of 40 times the time of 9. So it would be 360. I'm sorry, that doesn't look very good, does it? 360 miles was the distance. All right, you are just getting started on this journey of distance equations and how to set those up. It's going to get a little more complicated, so get good at it right now while you're working with equal distances. And good job. I'm really proud of you guys, and I'll see you next time for lesson 93.